Hello friends. Now we'll see what are the different properties of a relation. First and foremost property is reflexive property. A relation R on A is said to be reflexive if every element of A is related to itself. That means, say for example, let's take a set. Let's take a set A 1, 2, 3. This set is said to be reflexive only when if you get a relation like this 1, 1, 2, 2 and 3, 3. So every element of A is related to itself. So such a thing is called reflexive relation. Then we denote this as A is related to A for all A which is an element of the set A. So this reflexive property is like a mirror. If any person standing in front of the mirror, the reflection what we get is the same. For example, example of reflexive relation includes is equal to, whenever say this number is equal to 5, 5 is equal to 5. So then it is called reflexive relation. For example, in general, if we say, let's take Tom. Tom's height is equal to Tom's height. Yes, it has to be equal because Tom's height should be equal to Tom's height. Then it is called reflexive relation. It cannot be, it is impossible that Tom's height is not equal to Tom's height. No, that is not possible. So it has to be equal. So this is one of the example of reflexive relation. For example, if we say a relation like this, say 2, 4, if 2 is related to 4, 6, and 10, that means by saying this you can say that 4 is divisible by 2, 6 is divisible by 2, and 10 is divisible by 2. Also 10 is divisible by 5. So this is a relation. And also we know that every number is divisible by itself. So the number arrow what I'm typing like this on top of each number says that the number is divisible by itself. So in this it is called a reflexive relation. Reflexive relation. So this is called reflexive relation. We have something called non-reflexive relation. Non-reflexive in the sense which is not a reflexive relation. That means if I say some relation as like this is the father of, and you can take some example, Ram is the father of Ram. Is it possible? Anything like any person is Ram is father of him, he himself is father of him? No, this is not possible. So such a relation is called non-reflexive relation. I hope you are clear with reflexive property. Next, second property is symmetric property. Symmetric property. What do you mean by symmetric property? Symmetric property is nothing but a relation R on A is symmetric if A is related to B, then B is also related to R. For example, we can say is married to this is another example where I can say is married to, if I say Ram and Sita. Ram is married to Sita. So obviously Sita is married to Ram. So that means A is related to B and B is related to A. Such a relation is called symmetric relation. If I say, for example, if I take another relation is less than, say 3 is less than 5, yes, true. But if I say A was it 5 is less than 3, no, this doesn't hold good. Then such a relation is called asymmetric relation. Asymmetric relation. So this is how you define symmetric. So that means when A is related to B, then if B is also related to A, such a function is such a relation is called symmetric relation. Third property is transitive. In this case, a relation R on A is said to be transitive if a given relation, say A related to R, A related to B, and B is related to C. If these things are given, then obviously this implies that A should be related to C. If this holds good, then such a property is called transitive property. Say, for example, if I say a relation is equal to, if I say A is equal to B, then and B is equal to C, then A is equal to C. So such a relation is called transitive relation. This is called transitive relation. I hope you are clear with this. Next we will see equivalence property. A relation that is reflexive, symmetric and transitive is called equivalence relation. That means reflexive, if A comma A is belonging to that relation where A is an element of A, then such a relation is called reflexive. Symmetric means if An and A2 belongs to R, and this implies A2 is A2 comma A1 also belongs to that relation, then this is called symmetric. If it is a transitive, that means if A1 and A2 is an element of R, A2, A3 also element of R, then A1, A3 also belongs to R, where A for all A1, A2, A3, which is an element of set A. So when all these three relations are met in for a relation, then you call that as equivalence property or equivalence relation. So a common example of equivalence, we say equality, which can be a relation between real numbers or sets, and similar is similar to in the set of triangles, then you can say it is equivalence relation. Let's take an example. Say this is an example problem. In this case, they have given let T be set of all triangles with relation R, with R a relation will be given as, the relation is like this, T1 comma T2, such that T1 is congruent to T2. So let's take an example. We'll select some of them similar triangles. So T1, T2, T3. Okay. So if I say it has to be reflexive, then it should be related to itself. If I take a similar triangle, T1, a triangle, if it is similar, any triangle will be similar to itself, will be congruent to itself. So that means T1 is similar to T1. It will be similar to itself, or it is related to itself. Then reflexive relation is met. You can say any triangle, you can say T2. If I say select T2, it is a related to itself. That means it is similar to itself. Then this is it holds good for all set of all congruent triangles. Second property that has to be met is symmetry. Symmetric means, so if I take for example two similar triangles, if I say T1 and T2, T1 is similar to T2, then this implies that T2 is also similar to T1, correct? When I say these two triangles T1 and this triangle T2 are similar, obviously if T1 is similar to T2, T2 should be similar to T1. So symmetric property is also met. Third property is transitive. Let's select three triangles T1, T2, T3. If T1 is similar to T2 and triangle T2 is similar to T3, then obviously T1, triangle T1 should be similar to T3. That means, see, if T1, that is triangle T1, similar to triangle T2, yes, and triangle T2 is similar to triangle T3. Then, if these two are similar, if this is in this whole space, then T3, T1, triangle T1 is similar to T2. So all these relation holds good. Then we can say that the given relation R is equivalence. Yes, it is equivalent because all the three relations are met. Holds good for this particular relation. Then you can say that therefore the given relation R is equivalent. Yes. Hence, I hope you are clear with this.